All right, ladies and gentlemen, now we're going to talk about what the expected value is, and that's the average of a probability distribution. So that if we were talking about the hockey goals like we would before, like we were talking about before, we estimated based on the histogram what the average number of goals scored in a hockey game would be. Now I'm going to show you how to actually calculate it. It's not the same as a normal average. A normal average you're used to from like middle school and elementary school is adding up all the outcomes and dividing by how many there are. Well, this is different. Why is it different? It's different because now each outcome has a probability attached to it. So we have to take that into account. What is the expected value? The expected value is where we're going to take our first observation and we're going to multiply it by the probability of the first observation. Then we're going to take the second observation and we're going to multiply it by the probability of that second observation. Then we're going to do the third observation times the probability of that third observation. Let me make this smaller. Plus, we're going to just continue until we've done all of our observations in that sample space, or all of those outcomes in that sample space. That is the average of our probability distribution. Let's go ahead and try it with this one here. I chose this problem for a specific reason. The math department is going to have a stand at a local carnival. Participants can come to the stand and pay $2 in hopes of winning more money. The winnings are as follows. Blue is $0, light blue is $1, black is $2, orange is $3, green is $4, purple is $0, red is $2. There are 9 sections on the wheel. There are 2 blue and 2 black. The rest of the sections appear only once. Okay, what you should hopefully notice is we don't have a probability distribution like we did for the NHL goals. So what we have to actually do is we have to create a probability distribution if it's not created for us already, okay? So we're gonna go ahead and we're gonna do that now. I wanna look, and you can see here, I say first, I'm gonna put what X is. X is equal to the question. So what is the question talking about here? The question is talking about our winnings, okay? We want to know our average winnings. So I'm going to put winnings here. All right, next, second, I want to talk about the probability of those winnings. Okay, and now we want to talk about, well, what can we win? If we look at the problem here, you can see we could win. We're paying $2. We're not going to talk about that paying of the $2 right now. We'll talk about that a little bit later. Let's just talk about what we could win, though. We could win $0 here. We could win $1, $2, $3, or $4, okay? So let's write that out right now. 0, 1, 2, 3, and 4. And now I'm going to be mad at myself because bear with me, guys, bear with me. Let's just put W for winnings and then the probability of winning. I'm running out of room here. So 0, 1, 2, 3, and 4. Okay, what we know is we know that there are 9 spaces on this wheel, okay? So you can imagine a wheel with 9 spaces, right? So I know that all of my probabilities have to be out of 9. Okay, next what I want to do is I want to say, well, what's the probability of winning $0? So if we look at our problem here, we could win $0 on the blue spaces, and we know that there are 2 blue. Or we could win $0 on the purple spaces, and there is 1 purple. So that's 3 total places where we could win $0. So the probability of winning $0 is 3 out of 9. Now let's talk about how we can win $1. I can win $1 if I land on the light blue space here. I don't see another place where I can win $1 if I read through it. And so as a result, I can win $1 one place. So the probability of winning $1 is 1/9. Okay? $2. Let's look again. We know there's 9 spaces. We can win $2 on a black space, and we know that there are 2 black. Or we can win $2 on a red space. So that's 3 total places that we can win $2. Right here. And then it says the rest of the sections only appear once, so we know that it's 1 and 1 here, right? Okay. If we look at orange, there's only 1 orange, 1 out of 9 to win $3. And there's 1 green, that's to win $4, 1 out of 9. So now we have our probability distribution. The next thing it's asking is it wants to know our average winnings, okay? I'm gonna show you by hand, and I'm also going to show you using your calculator. By hand to use our app to find our average winnings, okay? What we're gonna do is the expected values, the expected winnings. This is the way that we can write our average or expected value. My expected winnings, also known as my average, is, remember what the formula says. If I scroll up, which it's not letting, there we go. I'm going to take my first observation times the probability of that observation. My first observation is 0 times the probability of that observation, 3/9, plus my next observation. So this was the first one. My next observation is 1 times the probability of that observation, plus, and I continue doing this, 2 times the probability of that observation, plus 3 times the probability of that observation, plus 4 times the probability of that observation. What I'm going to do now is I could do this completely by hand with my calculator. I could type each one in and add it all up, or you guys all have a graphing calculator on your Chromebook. I want you to know how to use that and make it work for you. So I'm going to show you how to put this in your graphing calculator to get the answer. What I'm going to do first is I'm going to get my graphing calculator out, so pause now and go get it if you haven't. I'm going to hit Stat. I'm going to hit Enter on Edit. I'm going to go up and I'm going to put my cursor on L1. I'm going to clear it out. So hit clear and then hit enter. Do not hit delete or it will delete this total column. Do not do that. I'm going to go over to L2. I'm going to highlight it. I'm going to hit clear and enter. Some people have errors in class when we do this together in class and they say, Miss Opal, it's not working. A lot of times it's because you don't put your cursor up on the L and then hit clear. So make sure it was up there to clear it out. In L1 now, what I'm going to do is I'm going to put all my observations. So that's my top row right here. So I'm going to put 0, enter, 1, enter, 2, 3, and 4. Again, this is all of my observations in L1. What am I doing right now? I'm showing you how to use your graphing calculator to compute this all a little bit quicker, I guess. And also I want to make sure that you know how to use this calculator, that you can become kind of one with your calculator. Most of you are going to take a stats class when you guys get to college, so it'll be helpful if you have some of this background going into it. It takes some stress away, right? In L2 now, we're going to put the corresponding probabilities. So the first probability is 3/9, so I just do 3 divided by 9, and that will put in 3/9 for us. The next corresponding probability is 1/9, so 1 divided by 9. The next probability is 3/9. And the last probabilities are 1/9. Okay, so 1 divided by 9 and 1 divided by 9 again. Okay, so I have my outcomes and the probability of each outcome. Now what I'm going to do next, so pay very close attention and pause along the way. I want to hit Stat. I see this screen. I want to arrow over to Calc. I see this screen. I want to hit Enter on one variable statistics. I see this screen. Now, if you have the old calculator, you can go ahead and hit Enter because your old calculator, it will automatically do it for you. But if you see my screen right now, you want to make sure it matches up to what I see. You want your list 1, that stands for your outcomes that you're looking at. And then the frequency of the list is our probability. So I need to put L2. If I don't have that, I hit second and L2. Again, the old calculator people, you'll just see one variable stats in your home screen. Just hit enter and it will calculate what we need. The rest of us are going to hit enter and calculate here. And we see this screen here. This X bar, you guys, this is our mean of the distribution. It is our expected value, 1.55. So I am going to round that to 1.56. And remember when we were talking about that distribution and we were talking about shape, outlier, center, spread, the center is the average, the expected value. The spread is the standard deviation. And that standard deviation is right here, sigma x, 1.34. It didn't ask for that right now, so I'm not going to worry about it. But it does say, or here, we do want to interpret this. What does this mean? It means in the long run, okay, a student or a customer can expect to win an average of $1.56 each time they play the carnival game. Now, there can sometimes be follow-up questions. A follow-up question might be, does it make sense for this person to play? Well, what do you guys notice? We have to pay $2 in hopes of winning money. And in the long run, it's saying, hey, $1.56 is how much we're going to win per game. Well, if we have to pay $2 for it and we only win $1.56, does it make sense for us? No. It does make sense for the math department, right? That means they're making money in the long run each time a person plays, okay? They're making money. So that's kind of how carnival or casinos, so on and so forth, they set it up to profit, okay? They make the probabilities work for them, where in the long run, they're gonna win money. Will they lose money in the short run? Sure, sometimes they're gonna lose some money here or there, but if you look over the course of the long haul, they are going to be winning money, or the casino or the carnival, the math department in this case, is going to be winning money. They're getting money from the customers in the long run, and you, the customers who are playing the game, are losing money. Okay. All right. What should we have learned from here? How to set up a probability distribution. You are going to have to be able to do that in your homework. How to find the expected value, the average winnings. That's the same. Those are synonymous. So when you see expected value, that also means average. How to show our work by hand, but also how to use our graphing calculator to get that as well. And then also how to interpret it. Thanks, guys, and I hope you have a great day.